You may have heard about the Fab Lab here at Metropolitan Community College, Fab being short for fabrication. The MCC Fab Lab is located here at the Fort Omaha campus in the Center for Academic and Emerging Technologies building. And it's a resource that's available for students and non-students alike. But what is the Fab Lab? Well, in short, it's a place where through digital fabrication you can create almost any object. It's the mean by which invention is accessible to nearly everybody. In a moment, we'll take a look at the equipment here at the Fab Lab, what it does and what it can do. I'm Kent Pavelka, your host on MCCTV. Hi everybody, my guests for this segment on MCC's Fab Lab are Michael Gerke, the information technology instructor here that we're chatting with, and Lindsay Gibbs, manager of career placement at MCC. Thanks for being available to chat about what's going on here. And I understand the name really isn't Fab Lab anymore. Michael?
Right. Now we're the Prototype Design Laboratory. We started a brand new degree in prototype design, and that's kind of what we're focusing on now.
Prototype design.
Yes, sir.
So when it was called the Fab Lab, what are we talking about with fabrication and prototype design? What is that about?
So we want to be completely accessible for anybody in the community to come in, have an idea, and create it take their idea from the initial concepts in their mind to sketch prototypes out to an actual physical product that they can hold, show, and see in 3 dimensions.
But prototypes takes in a lot of territory here. Prototypes of what? What's the landscape about what we're trying, what you can possibly fabricate here?
So we've ranged materials from plastic through 3D printing. We do a variety of digital electronics, so we wire together basic circuits and circuit boards. We do a lot of wood prototyping, and now we're venturing into metalworking and metal products.
If you think about it, who doesn't want to hire a prototype designer, right? Because if you can take any type of idea, whether it be, and any type of idea you want to make a physical concept out of, it could be a skin graft, it could be a bone to help build new devices, it could be a new cell phone cover that fits cell phones better so then we don't have the issues of dropped calls or whatever that might be. I mean, truly, it's any type of idea. It might be crazy, but you could potentially make it here in the lab.
So how does that interface with what you can do as far as majoring in this?
Absolutely. So it is a degree program, full associate's degree program. They will leave mostly focused on technical skills. We do have some gen ed still in the degree program, like your math and your English, some humanities. However, we focus on the core skills. Almost every single machine that you see in this lab, they will develop some type of training and projects that they will have to complete, mostly in a group setting, because let's be honest, in the real world, everything is mostly group work, so learning a little bit more collaboration and communication. And really that's the core of what our program is what type of projects can you build using these different machines that are applicable to the real world.
Yeah. Well, tell us about all the equipment here. What are these? You got tons of things. Those look like huge copiers to me.
Every single machine essentially is a printer of one sort or another. So we have 3D printers, which is a hot glue gun. You hit print and it moves a hot glue gun around and squirts out some plastic and creates a part. Those big red and white machines, those are actually laser cutter engravers. So they use a CO2 powered laser.
What does that do? A laser?
It cuts. Lasers, it's a big light bulb essentially, and we're emitting infrared radiation, infrared light.
So you would have what in there that you would want to cut, for example?
Wood, paper, cardboard. It'll etch stone, glass, marble, but it won't cut those materials. Essentially, it cuts wood up to about 1/4 of an inch thick.
Yeah.
From that, you can laminate to create 3-dimensional structures, or you can cut it in such a way that they join together later.
Well, let's look at the equipment maybe from start to finish. I mean, if I come in here and I say I want to create a new cell phone cover, where do we? If I don't know anything about fabrication, where do we start? Or am I even allowed, with that limited knowledge, to do a project?
Oh no, of course. That's already more advanced of an idea than a lot of our users come in with. You already know that you want to make a cell phone cover. Most people come in and say, I have an idea of something, and you go, how does that work? But a cell phone cover is simple. So what you would do is you would have your phone, we'd figure out the dimensions for it, then we would create a paper sketch, then create a three-dimensional sketch on the computer, and then start printing it.
Which of these computers are we talking? Any special computer? Any
Nope,
computer?
any computer. We run SolidWorks for our three-dimensional CAD software. It's pretty standard industry-wide. So we can create any sort of three-dimensional object, software side, and then we can design on how we're going to physically create that product.
So now we've got a computerized sketch of the cover.
Right.
Then what do we do?
We hit print. We throw that computerized sketch on a 3D printer. We hit print, comes out. We see if it works. Plastic's cheap, so we always.
You mean it comes out as the product?
Yeah. At least on the printer anyway, the 3D printers. Then you just pull it off, see if it fits, make any adjustments necessary in the software, and then we decide on what material you want to make it on and how to build it. And then from there, it's pretty much unlimited. There's no right and wrong answer.
Right. We typically allow students, we want them to fail. We want them to fail a couple of times because it's an iterative process. We want you to get to the point to where you're okay with your product not being 100% that first time around, because once you go through multiple iterations, you're going to find you're learning so much more. You're learning how to make it better, how to make it within standards of what maybe a client in the outside world would want, maybe even what a producer would want to see. Ideally, when you're working on, let's say, that cell phone cover, what would the industry want? If you wanted to actually make a living off of this, how would you make it
Something new.
something new,
different.
something different that a clientele would want? And then how do you price market? So again, it's, yeah, that little project, but so much more than that. How do you
Sure.
become an entrepreneur from that? How do you sell this to a business as a prospective, business plan?
Sure. On the other hand, what if you're working for a business? What kind of thing would I come in here representing a company wanting to do?
We have tons of businesses that already come in.
The last person who came in last night was just making some round steel a little smaller in diameter. So he's a business, he's an architect, and he's designing new doors they weigh 600 pounds each, so we needed a way to hold it up in the ceiling. So his steel that he buys from the manufacturer is a little too big, so we had to make it a little smaller. So our business partners come in with doing very simple alterations like that, up to coming in and engaging our students and having them design out a product from the ground up that our students then build for them, at least the prototype phase, to see how it would all work, and they could take it back to their actual manufacturer.
Why would the employer want to use the students for that?
It's a win-win situation for us. So the students get exposure to real-world projects. They get to put that on their resumes, and then the employer gets essentially cheap labor and good designs.
The one thing we ask for that employer is that you truly make this a mentoring opportunity, because when they leave, we want to make sure that they also have references, right? So yes, they have a portfolio of things they've created, but if I was an employer and I'm looking for somebody that might be an engineer, well, these students aren't going to leave the program being full-out engineers, but they have some of those basic principles that engineers already have. So having that reference of that employer definitely helps with that employment opportunity.
So there's no cookie cutter
No.
job that fits every graduate, right?
No, in fact, if you look online, like on Dean, look for prototype designer, you won't find any in Omaha because it's not really a job. You can find some in Europe, I've found, but over here, it's not a job at all. We're trying to get the students to find things that they enjoy doing and specialize in that field. We want them to learn a variety of skills and learn how to think critically and apply those concepts to cross-train into an actual field.
But as an employer, if I often find myself in need of what a prototype, what do you call them, technician can do,
Yeah.
I don't hire one, I just continue to use MCC as a resource, or how does that work?
Well, we hope that they do hire them.
Yeah.
I mean, that's the ultimate goal. Usually when they see our students are doing very well, it gives the employers an opportunity to vet our students while they're working with these first stages. From there, why wouldn't you want to cherry pick the best of the students?
Sure. Let me make sure I understand. So the machine has spit out this plastic model of my cell phone cover. What's the next step to actually produce that in its final form? Do we do that here?
Yeah, all of that can be done. So if you have a plastic model that works, you've done all the tweaks, now you know what your final material wants to be out of. Maybe you wanted a mixture of resins and a metal cover to it, we can create all those different parts and start assembling the one-offs.
What machinery do we use to do that? Or different machines?
It'll vary
Yeah.
on every single product. That's why the students, they're not experts on any of these. So I'm not training CNC machinists, I'm not training machinists, also not training 3D printerists, I guess. But they have a basic loose understanding of everyone. We consider them jacks of all trades.
But you've got those machines here.
We have the machines here, and they are able to be used.
Do you as a student then, first of all, what's the degree in?
The degree is prototype design. It's an applied associate degree in prototype design, and our main focus is technical skills. So when they walk away, they should be able to know how to work a CNC plasma, CNC router, a welding machine, MIG-TIG. They'll know how to use all of our basic woodworking tools, several different 3D printers using various different materials. They'll also understand what the process is from idea, from sketching, all the way to how do I take the sketch and put it into a digital format, and from that digital format, then how do I determine what machine is going to be the best suited for what I'm trying to design.
Okay, so I think I've got the picture then. You as a student, I have an opportunity to assist a business that wants something produced.
Absolutely.
As kind of a real world test, but as a student also, you're gonna educate me on everything that's in here and how to do it all.
And we focus a lot on problem-based learning. So we give our students these problems that there are no answers for. Like your cell phone case, there's no real answer. I can make it a million different ways. They have to come up with their own solution. And sometimes their solutions are very good. Sometimes their solutions don't always fit the problem.
Well, does that have to do with the entrepreneurial element of it, of trying to make a better cell phone cover?
It does
or a
very
unique one?
much.
Yeah.
It could, definitely.
Well, this is very cool. Just comment briefly on the coolness factor of everything you've got here. I mean, there aren't many places like this around, are there?
There are a couple maker spaces in Omaha. So we have the Omaha Maker Group. We have that Spotted Do space. Even MCC has some stuff on the top floor of the Do space, all kind of in the same realm. So they have some 3D printers and some laser cutters, where we kind of take the next step is we have much bigger machines and we're still open to the public. So we do charge people to come in and utilize this stuff, but we will train them on the heavier duty machines.
So we do have a community membership, and the other thing we try to make fairly easy for students is to embed material costs into the cost of their classes. So that way they're not having to pay tuition and then 3 weeks later, oh no, I have to pay $200 for wood. We try to embed as much of the cost as necessary in order for it to make it easy to access anything that we have in the lab.
So if I'm serious about my new cell phone cover, what do I do? I contact one of you, and what's the process then for doing it?
Would depend on if you want to do it yourself. If you have a solid idea, you want to just be trained on the software and the machines, we could do it that route. Or you can come in and present your idea to a class. Different students will have different takes, and you can work back and forth with the students that you would enjoy and their ideas that best fit your product, and you can see what's created at the end of it.
Would you guys show me around and kind of point out some things here for me?
Not a problem.
Because I may want to come in and do something.
I hope you
Absolutely.
do. Give a project to one of my students. They like real world applications.
And they work really quickly.
I think I got to come up with a better project than a cell phone cover.
Yep.
Probably. But.
We have our first student graduating at the end of this quarter, our very first. Next quarter, we're projecting 3 to graduate, and then this summer will be our first cohort, our first year that started 2 years ago in the fall. They are projected to graduate at the end of this summer, so we're really excited. Yeah.
So check it out, mccneb.edu/ what would it be?
Is it
Workforce Innovation Division?
Yep.
I'll have to double
Workforce
check.
Innovation Division? Well, you'll find it.
Right.
Yep.
But that answers the question, how do I pursue this, right? Check it out
Absolutely.
online first?
Yep.
Very good.
And if you're interested, we can
Or
get them in for a
stop
tour.
in.
Stop
I'm
in.
here. I'm here.
What's the hours?
We're open 9 a.m. to 10 p.m. Monday through Friday, and 9 a.m. to 4 p.m. Saturday and Sunday.
Don't need an appointment? to
Nope,
come
walk on in, we'll help you out.
It's the AET building on the,
Yep.
on the Fort Omaha campus. And there you have it, a look at what we're doing with prototype design at Metropolitan Community College. Our thanks to Michael and Lindsay. I'm Kent Pavelka for MCCTV.